Good afternoon, everyone. Today, our esteemed guest is Dr. Muhammad Ashraf. Sir is Principal Scientist at ICR. We welcome you, sir, on behalf of NADCL, on behalf of students, and on behalf of the organizing committee. Sir, please continue.
Good afternoon. Can you hear?
Yes, sir. Yes, sir.
Okay. I am Muhammad Ashraf P. I am working as a principal scientist in ICAR Central Institute of Fisheries Technology, Cochin, India. And it is I belongs to the Fishing Technology Division, where we have a small section. It is called Material Science and Environment. And this institute, I just tell you in brief, this institute is Central Institute of Fisheries Technology, belongs to ICAR, and this institute works on two aspects. One is how to harvest the fish, and second one is the harvested fish to process and it made available to the consumers in safe way and hygienic way. For that, we have several divisions, around 7 divisions, and each division taking care of fish hygiene, microbiology, fish processing, and quality, like biochemistry, etc. So fish harvesting also, the fishing technology division. So that is what just to say. This is the Central Institute of Fisheries Technology, and you can see more detail in our website. Oh, okay. Then we have 4 centers in India. One is in Gujarat, one is Verawal, the other one is Visakhapatnam, the third one is in Mumbai. So my talk is just a brief about the history of this nanomaterials, nanotechnology, and then nanomaterials, its classification and application, and what are the research carried out in Central Institute of Fisheries Technology in nanomaterials, and then conclusion. Coming to the introduction, we are come across so many industrial revolutions. One is the steam engine, steel industry, automobiles, then semiconductor industry comes in 1950, and 1980s, nanotechnology and molecular manufacturing were evolved. And that is continued. And when the nanotechnology got the presence is Dr. Feynman. We have to remember him, an American physicist and Nobel Science winner, pointed out that there is a plenty of room in a conference. There is a plenty of room at the bottom. This is that is what he specified. That means why can't, because of that small small particles, we can write entire 24 volumes of encyclopedia. That day he told we can write it in a head of the pin. Or his vision is was to develop smaller machines down to the molecular level. Further, Feynman explained that the laws of nature do not limit our ability to work atomic and molecular levels, but rather what is lacking at that time was the instruments which can see the lowest, smallest size of the particle. For example, he often and this Dr. Feynman is considered to be the father of nanotechnology. Well, and also he pointed out when we have some, so okay, he also told that if you have a control over a particle, for example, if you can make smaller and smaller particle, and each will have different possibilities, greater possibilities and greater properties. So the problems of chemistry and these properties can be solved, the problems of chemistry and physics and biology. And you can see here this figure, the particle size increases, there is a gold nanoparticles, and it increases, the color of the solution also changes. So that means it has got its potential of, if it is particles smaller and smaller size, it has got its own potentials. So the nano size means it is 10 raised to minus 9 centimeters. 9 nanometers. So the term nanotechnology was introduced by Taniguchi, a scientist in Japan, in 1974 during a conference, Japan Society of Precision Engineering. According to you, the term nanotechnology means a domain of scientific activity oriented on synthesis, investigation, application of devices and materials, and technical system whose functioning is determined by nanostructures. The typical size of nanoparticle is 1 to 100 nanometers. So the nanotechnology means that it is the research is now speeded up, and day by day it is growing. And how it has happened, because the introduction of scanning tunneling microscope, atomic force microscope, and the motivation to develop hard disk that is this high storage density, high storage devices which can store large volumes of data, and the electrostatic and magnetic forces using measurement of electrostatic and magnetic forces. And currently, nanotechnology is rapidly evolving every day by day. And now powerful characterization and synthesis tools are available. So hence nanomaterial with better controlled dimensions and all we can synthesize. So in view of these characteristics, we can prepare a lot of nanomaterials, and it can apply in different field of chemistry, physics, like that. So in general, this is the size of the nanoparticle is the 1 to 10 raised to 2 is the size of the particle. It comes under liposomes, dendrimer, gold nanoshell, quantum dots, fullerenes, etc. comes under this size. Okay. And in simple terms, what is nanomaterial? Nanotechnology. Nanomaterial means why it is so important. So you take one sugar cube of 1 square centimeter. What is the area of that? 6 square centimeter. And you made it to two pieces. Then the area increased to 8 square centimeter. Then again 4 pieces, 4 equal pieces. Then it comes 10 square centimeter. That means the increase of surface area available for reaction is 66%. If it is a macro particle, you made it to smaller and smaller particle. Each particle will provide a space, a surface area for reaction. So that means it is different. Then the same sugar cube, you crush it, enormous number of particles will be there, and the surface area will become very high. So that is if it is smaller and smaller particle, each particle will give you a surface for reaction is. So that means the surface area is enormous, and these all surface will participate in a reaction so spontaneously. Then we are expecting a very good result, very active reactions and active results. So generally we have seen nanoparticles. Nanoparticles you can see, nanoporous structures you can see, then nanotubes and nanofibers, nanodispersions, nanostructured surfaces and films, nanocrystals. These are all some of the characteristic material available in the nano. And generally, what is how we can synthesize a nanoparticle? Top-down approach. Top-down approach means you have to take just like as I told you in the sugar cube, you have to take a bigger macro particle, then you have to crush it into smaller and smaller nano-sized structures or particles. That is the top. And the biggest problem in this methodology is the top-down method is the imperfect. The size will not be uniform, and the crystal will not be the same, or it is different imperfections will be there. And then bottom-up approach is just I am talking about this just the simplest way. Second step is bottom-up approach. Under this approach, we have to do the build-up of a material from the bottom. That is atom by atom, molecule by molecule, or cluster by cluster. It is considered to be the more economical and feasible method. Most of the nanomaterials were produced in this bottom-up methodology. And then one is the solid gel method. Here, the liquid is converted to into a solid gel network. And then physical vapor deposition means we have vaporized the material into the macroparticle into vaporize the material and then condense it to thin films. Then it will form nano-sized particle. And chemical vapor deposition means the chemical reaction. We have to vaporize this material, and the reactions happen in the gas phase. And it is deposited over a surface, and we'll get a nano-sized particle. Molecular beam epoxy, epitaxy is one of the methodology. Here the thin films were grown in atomic layer by layer, and then spray conversion processing, and then wet chemicals. Several methods are there to produce this nanomaterials. Some of them I have listed here. And then what is the importance of nanomaterial? It has got high surface area because the size is less, large surface is available for reaction. So magnetic properties, non-magnetic become magnetic in nano level, quantum effects, high thermal and electrical conductivity, high mechanical strength, excellent support for catalyst. Because if you are generally a macro material you are using for 1 gram, that in place of that you can use only not 1 gram for getting such a catalytic effect. Then antimicrobial activity. If you are thinking of nanomaterial, they are thinking the amount of nanomaterial used for your experiment should be very low amount, not in percentages or like that. 0.01%. You can think 101, 0.01, 0.02, 0.05 like that. Then you can increase if it is if you are not getting desired results. And then what are the different materials? Nanomaterials. Several inorganic materials are available. Inorganic oxides are generally seen as a nanomaterial, but here I am talking about the carbon and its analog as a nanomaterials. One is fullerenes. Fullerene was discovered in 1985 by Robert Karl, Harold Proto, and Richard Smalley. What is a fullerene? It is a buckyball. It is called buckyball, and it is having around C60 molecular weight is C60 molecule, or it is like a tube-like model and with cap and all has seen. And so the number of carbon atom in this fullerenes ranges 20 to several hundred atoms. And then another one is carbon nanotubes. That nanotubes means that it has discovered by Sumio Lijima, and it is a flat structure. You rolled it into a pipe-like structure. That is called carbon nanotubes. And multi-wall carbon nanotubes also we can see. That means it is from 1 or 2, 3 layers of more number of layers will be folded into a pipe-like structure. That is called multi-layer carbon nanotubes. This is carbon nanotubes are single or multi-layered. That depends on, and the diameter will be around 0.5 to 100 nanometers in the case of a multi-layered structures. Okay, see, you can see this is the graphical representation, and you can see here if you are looking through an transmission electron microscope, it will be like this. Okay. Then the third carbon is coming as graphene. The graphene is discovered by Andre Geim and Konstantin Nossolov, and both received a Nobel Prize. What it is, the graphite, you can see graphite is a CC bond, and you have taken a single layer of graphite. That is a 2-dimensional structure, and it is just that thin layer, one layer of carbon sheet is called graphene, and it is at present it is the thinnest material in the universe, because one or two atoms will be there in a layer, and the strongest material ever measured, the best conductor of heat and electricity, smallest effective mass. And this is the structure of carbon graphene. That graphite, you put it, you separate out each layer of carbon. Okay. And this is the structure of graphene, because you can see sp2 hybridized orbital. All the 3 sp2 hybridized orbitals were combined with another carbon, and then the pi bond, pi sp2, pi orbital is available, exists as independent. Okay. Then these are all the several properties are there: mechanical properties, tensile strength, then optical properties. So many. So you can read so much electrical properties. It is excellent material for using for different purposes. So in view of that, we are using several purposes this graphene as a material for antimicrobial, and then if you want to do some reactions, or if you want to develop some sensors, and all, you are using this graphene. And then comes to carbon nanodots. This carbon nanodots means it is a structural, it is a carbon, this type of structure, but it containing nitrogen, oxygen, and nitrogen, carbon, and nitrogen, oxygen, etc. That means it is a graphitic structure, but it containing other functional groups. So how we can this for example, carboxyl groups devoid of metals, it will not containing any metal and all, but it contains only carbon, nitrogen, and oxygen, or sometimes sulfur, or sometimes phosphorus, and that depends on this one. And mainly major contribution is from carbon only, but the other things also will be present. That means it will give you a different type of character. This is the structure. This is the transmission electron microscope image of carbon nanodots. And how we can this you can see here under visible light the carbon dot will be a brownish solution, but if you pass through under UV light it will give you a fluorescent very high fluorescent images. So that means this is the we can do a lot of things with this material. Actually, I am working with this carbon nanodots and its application in uh, anti-fouling, development of anti-fouling strategies. Okay, these are some of the, we can prepare any waste material like glucose, cabbage waste, or hydrosan, food waste, orange juice, whatever it is. You can do hydrothermal reactions or some other ultrasound, or sometimes you can do electrical heating or whatever way, ashing. You will get this carbon nanodots, and it is a highly fluorescent in character. So the major application is it is used for a very bioimaging as a tool for bioimaging. Zinc sulfate dot, the carbon dots were used. Carbon dots were passivated polyethylene glycol as used as a you can see this fluorescence images, and then biosensing also you can do that sensing of different characteristics, different molecule or aptamers or different molecules you can using this carbon dots. And then you can food quality control, explosive screening, whatever methodology, carbon dots were extensively used for different different purposes. And then in our lab, we have done some small works on this anti-corrosion characteristics of fluorescent carbon dot incorporated, all coated as steel, and it is incorporated in epoxy resins. And then we found that it is working fine. What in case of epoxy resin, what we have seen is that the surface become more. Actually, if it is epoxy resin, one of the major issue is that large number of pores will be seen. But if you are using carbon dots, these pores were closed because of the carbon dots. That is one of the advantage. And these carbon dots mainly we are synthesized from fish skin or prawn shell or fish scale, etc. And then another work is that phosphorus doped carbon dots you have used for different same epoxy incorporation. Then environmental monitoring by using development of sensors using different types of carbon dots. And then in that we have recently done a small work on that a sensor of using a carbon dot composite for analyzing mercury. Okay, these are all the instruments. If you are talking about the nanomaterials, you have to scan with the transmission electron microscopes, scanning electron microscopes, and X-ray diffraction, atomic force microscope. These are all the instruments used for characterizing or analyzing the properties of nanomaterials. And then I already talked about the food science. It has nanomaterials are used to enrich the food material, and fortified food products were prepared. Functional food, encapsulation, nanometer size delivery system. Even most of our cosmetic products are coming with a large number of nanomaterial. For example, your face pack, those who are using face packs which give you glow. Then for that, containing nano titanium dioxide and some other inorganic oxides were present, or some organic materials also are present. So that what is the rationale behind these using these materials are earlier they have to this titanium dioxide they are using means they have to use more, but here you have to use very little amount, but you will get a very good results and it will not be seen in that. And but what is the problem is that whether it is absorbing the body and all is an issue, but that we are not talking about that. And then these are in a pictorial representation. The application of nanomaterial food science and technology is like this. We can use nanosensors, formulation, delivery, packaging, product formulation, product processing, and then preparation of emulsions, composites, nanostructured materials, and all. And then I will come to that one case study, what the development of an anti-fouling strategies in aquaculture cages. That is my area of research. And then the biofouling. What is that? When a material immersed in an aquatic environment, what will happen? Well, first immediately it forms for example, the proteins and other organic materials will attach over the material, and then this will be attracted by the microbes, and then it will form a biofilm. This biofilm, bacteria or diatoms, and form a biofilm. This allows settlement of spores of algae and settlement of microorganisms like barnacle, etc. Okay, then this biofouling will become a problem, especially in the case of aquaculture cage nets, ship hulls, underwater sensors, culture, everywhere it will become it will flow. If it is a aquaculture cage nets, if there is a problem, it will clog the lumens of the cages. So after that, the circulation of water between the cage and outside will be inhibited. So that means if a large number of nutrients will be floating around the cages instead of dispersing outside the cage. And these are all some of the issues, and that will increase the chances of getting sick of our fish. Okay. So aquaculture is very important because aquaculture is because if you want to feed the people of India, we need proteins. The best protein source, cheap and best protein source available is from water only. So we have to look into the this is a major technology coming up in near future, and it is there only we will get maximum returns and feed the people also, because land area is reducing. And these are some of the aquaculture cages in different places. It is some of them are in Philippines, some of them are in India. And then we know that what is the major issue is aquaculture cages are generally prepared with a fabricated way using high density polyethylene. That is polyethylene. What is the structure of polyethylene? Polyethylene is CH2, 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 CH2. It's a long chain molecule. What happened? It is not containing any nitrogen, oxygen, or sulfur, whatever it is. No other functional groups were present in the system. Then what will happen? Earlier also, the people are trying to make aquaculture cage nets to coat with different types of anti-fouling molecules. Anti-fouling molecules, the simplest anti-fouling molecule is copper oxide. Copper oxide, but it is not possible because it is highly non-polar system. That means it will not absorb. So what they have done is so many works were carried out to coat this aquaculture cage nets with different types of paste, gums, and this. What is the gums and biocides? For example, copper immersed in a gum and all. What is the disadvantages of using gum and all means? Whenever it forms a composite, the activity of the copper will not be good. So that means it will become, the effectiveness will be very low. So to avoid that, what we thought of that, instead of, first we have to modify the surface of the polyethylene because it is non-polar. So we have to make it polar. That means to add some conducting molecules like polyaniline. So we tried to synthesize polyaniline over aquaculture cage nets or over the polyethylene, but it is by immersing or something like that, but it is not at all working out. Then we thought to synthesize in situ. That means we dip the aquaculture cage nets in polyaniline, so aniline solution, and then polymerize the aniline to become polyaniline, and then during the formation of polyaniline, this will be attached over the net. So that then we have got a very uniform coating of polyaniline, and this will be like this. This is a pure polyethylene. This is the polyaniline. What is the bluish green color? And then third one is a actually then over this polyaniline now the surface is become polar because now it is ready. But you will not find that a polyethylene containing polyaniline. You can by color you can say that polyaniline is added over that. But by seeing it is there is not much changes in the net. So aquaculture cage net, so just it is just as flexible as earlier. And then we have then another thing is we have to add a biocide. Polyaniline is not a biocide. Polyaniline is we have made a polar molecule over that. Then we have immersed this polyaniline solution in nano copper oxide solution of 0.02%. I'm talking about 0.02% of solution. And then we found that a nano copper oxide was uniformly coated over the polyaniline and coated aquaculture cage nets. And what is the structure of polyaniline? This is the polyethylene surface, and this is the second one is the rod-like. This is the polyaniline rods, and rod-like structures were formed over the aquaculture cage nets. Then over that we have added nano copper oxide. The third figure shows that polyaniline coated polyethylene with the nano copper oxide. Okay. Then this is the atomic force microscope. You can see that this is proved that it is the copper oxide is embedded over the polyaniline molecule, polyaniline layer. And then this material we have exposed in the marine environments in 15 days exposure, 90 days exposure, and we can see that this is the control. And then nano copper oxide treated net has shown very good resistance to the fouls. And this is the real sample we have exposed in the Visakhapatnam border, Visakhapatnam Sea, and we can see that the control is having large number of different types of fouling organisms, but it is free from everything. And similarly, this is a freshwater system. Sorry. This is a freshwater system. Sorry. Freshwater system, you can see that this lot of algae was formed over the control sample, but here you cannot find any much. It is, I cannot say that it is fully free from, but it is comparatively good. And then we have done a small work on multi-location field trials. We have prepared aquaculture cage nets with treated and untreated net over the, and then we have made a cage and exposed to the marine environments of southern Kerala, and then we can see that the coated cages are comparatively good biofouling resistance compared to this untreated one. And then we have grown the fish in that. You can see that the different. This is just the same time we have kept in a hatchery. Well, then this is a cage culture one. We can see that the quality of the fish was very good, and then we have analyzed the fish tissues, guts, and gill, everything. We found that none of them is having higher amount of nano copper oxide or copper oxide in the tissues or gill or whatever it is. So then we have checked whether what are the different types of organisms were present in this. Then treated one has very few number of organisms were present, but in the untreated one, different numbers of different characteristics organisms were attached. Then same one toxic studies we have carried out in our lab, and then we found that bioaccumulation in copper in initial, if it is higher concentration, there is a higher accumulation, but it is natural. But you cannot say that it is not accumulating much on the lower concentration one. And then with the leaching of copper, we always talk about the leaching. We have first we have seen that the leaching was initial first 1-2 days. It is comparatively higher. After that, it becomes very common because most of the leached items were from the loosely bound copper over the polyaniline. And these are the conclusion. I'm not talking about that. And again, one of the major issue was that polyaniline, it is little bit processes, the in situ synthesis of polyaniline is little bit cumbersome and a lot of waste will be there. So to avoid that, we have devised another new molecule called an organosilicon compound. And then how this concept came is organosilicon compounds were extensively used in uh, this cottons. Cotton is also a non-polar system. And then these were used to, cotton fibers were used to modify different types of colors or different UV materials and thereby using this material. So what we thought that we have devised a methodology by using 3-glycidyloxy propyl trimethoxysilane. This I generally used to say silane, and we found that it is very good. It is very successfully attached over the aquaculture cage net, and then over that we have added copper oxide also. And these are all the characterizations used for characterization, SEM and all. We found that this were very good attachment. And then this is the UV visible spectroscopy, fluorescence. Actually, these are all the carbon dot we have prepared from fish eye CD, and it is fish eye we have used as a carbon waste material used as a carbon dots synthesis, and then we found that these are all the characteristics of fish eye CD. And then this we have prepared this fish eyes carbon dot plus a graphene. I told you both are the carbon material. Earlier we are all talking about nano copper oxide, nanotitanium dioxide. People will be very much worried because it is an inorganic material, and we used to say that it will become a problem after some time. Then we have thought of using only carbon dot and graphene. Both are carbon-based material, and it is highly degradable also, and it is having less toxicity characteristics. And we synthesized this through hydrothermal method, and we can see that this carbon dot you can see very small molecule, and here this shows that there is no inorganics, only organics carbon will be there. That is why it is showing. Otherwise we can see some crystalline structures, and this is the FTIR, this is the lowest one is the XRD structure, XRD, and all showed that FTIR showed that the CC bond system of carbon dot is interacted with the graphene, and then it is like a layered structure. And then we have studied the antifouling characteristics of this carbon dot graphene system, and we have treated different types of treatments, and then we have exposed these aquaculture cage nets into marine environment for 8 months. We have seen that these treated nets were comparatively good, and then this is the one city we have come across with the Mytilene. Mytilene is one of the major issue in Cochin region because it is a invasive species, and our treated nets were better to control this system. And then we found that H2 is a better overall study. We found that H2 is a better H3 is CD graphene has higher biofouling inhibition. And then now I will talk about the application of nanotechnology over biofouling control. Now we can think of how a nanomaterial can be synthesized from an organic material. For example, fish scale. This is the structure of the fish scale. Fish scale is a wonderful material, and it is how it forms. It is an osseous, transition, and matrix, 3 layers. It comprises of osseous, transition, and matrix layer. The outermost osseous layer, what is that? Containing hydroxyapatite, and then collagenous protein, and then this were interwoven by using different types of calcium materials. These are all the overall structure of the fish scale. So it is a plywood-like structures. And then we know that if you are extracting collagen, you will lose chemical methods, you will lose hydroxyapatite. If you are extracting hydroxyapatite, collagen will lose. So what we thought that we can convert this collagen to carbon dot, and then we can extract hydroxyapatite as a material. So, and this based on this concept, what we have done is a small methodology was developed by the fish scale was you treated with the hydrothermal reaction, and we prepared carbon dot. And then this we have got a solution including carbon dot and hydroxyapatite. Hydroxyapatite came as a precipitate. So that precipitate we have filtered out, and then we have sintered to 1000 degrees centigrade, and we have got a white hydroxyapatite. And you generally hydroxyapatite, my colleague also prepared. It is a highly nano-sized particle. That is the advantage. Instead of earlier, we are talking about the hydroxyapatite, which generally comes with a higher particle. Here we are getting very fine nano-sized hydroxyapatite, and it is white in color. That is also important. Generally, you will get a off-white or somewhat very light off-white bluish like color. And then here we are getting very pure hydroxyapatite, and this is the structure of that. And then again this filtered solution containing carbon dot. And then in this carbon dot, we found that some of the crystals were found, and then we have reduced the volume that evaporated to dryness of this carbon dot, and then we found that good crystals of calcium salts, and then that also we have taken out. And then this has again we have exposed to sintered to 1000 degrees centigrade. We have got beta dicalcium phosphate. So in this we have got three products. One is carbon dot, the second one is hydroxyapatite, and third one is beta dicalcium phosphate. So in single process we could manage to prepare these three method products. And then I will talk about the carbon dot we have synthesized from collagen. Collagen protein and peptides were converted to this carbon dot. And then the characteristics, generally you will get two peaks in a carbon dot. One is the major peak. The major peaks comes around 220 to 230. And what does it mean? It is a CC double bond. Generally, collagen this carbon dot is a conjugated carbon CC bond system, and this conjugated CC bond system will show around due to the pi to pi star transition, and then 263 the N to pi star, the carbon CO bond or CN bond, etc., will show at the second peak. Here itself you can see that the intensity of the peak of CC double bond was very high compared to the CO bond, CN bonds, because that means the carbon dot containing large number of carbons than other bonds. Okay. And then this is the carbon dot. You can see here. This it is thin film, very minute. It's less than 2 nanometers, and then that I can say smoke-like structures. And then this is the atomic force microscope image of this one. And this is the nano hydroxyapatite we have synthesized. These are all the UV visible spectra showed that the characteristics of hydroxyapatite, and it is comparable. Major absorption visible ranges characteristics of hydroxyapatite. That is what I can say that. And you can see that the first one is fish scale, the second one is hydroxyapatite, third one is scale after removal of hydroxyapatite. Then this I told you the third one is beta dicalcium phosphate, diphosphate. That is a material we have got, another material we have got, and this is also from fish scale. I'll talk about what is where it is coming. This also we have got the XID patterns and are comparatively comparable to the standards of 14313 of ICSD, and this shows that beta dicalcium phosphate is also you can extract from this material, this fish scale. And then what is the mechanism of this one? When we have taken fish scale and then we have added acetic acid solution, then what is happening? When we heat it at 180 degrees centigrade, this our fish scale undergo a little bit expansion or relaxation. Then immediately the acetic acid will attack the calcium, penetrate and cut the calcium link between the collagen and the hydroxyapatite. The collagen and the hydroxyapatite. That means it will change the orientation of all structures, and then it will become degraded, and then hydroxyapatite will go away, and then this collagen is converted to carbon dot, and then the calcium is used to intermovement between the hydroxyapatite and collagen. That will be separated out. So we can get a very good the three system we could extract. That is the basic reactions undergoing this process. Okay. So by using this, we have published a paper on carbon dot hydroxyapatite composite. The carbon dot, we know that, and then hydroxyapatite we know is a light brown. Then we have synthesized a carbon dot hydroxyapatite composite, and this is what we are telling that it can be used as a bond related experiments. And this is a summary of the flow chart. I'm not going too much on this aspects. This I have already explained to you. Then another aspects we are working on the preservation of wood. That is how the wood preservation is carried out. And earlier we are all using wood as such and the marine environments. And what is the major issue is all borers and other organisms will attack. And these borers can be prevented by the general fisherman is doing what? They will use different types of cashew shell oil liquid or sardine oil or different types of oil. They will coat over that. What is the purpose of this oil? To prevent, it make it as a barrier between the water and this wood. So nothing, no anti-biocidal effect and all. So then later in CIFT itself, they have come out with a technology that copper, chromium, arsenic treatment can reduce the borer attack, and we can use this wood for longer years, and we can preserve the wood for if we are using in a cano construction. So in that way, we have prepared a lot of canos and based on this technology. For example, in the case of Hevia silensis, that is a rubber wood. It is a very cheap wood, and that will not be lasting not more than 1 month or 2 months in the marine environments. That has treated with copper, chromium, arsenic, and we found that it is stable, and we have constructed around 9 or 10 canoes using this CCA treated wood, the rubber wood, and then it undergone some degradation only after 8 years or 9 years like that. So it is a good technology. So where the problem is that we are using very high amount of copper, chromium, arsenic. Instead of that, what we thought that instead of using that much amount, if we are using nanomaterial, as I told you in the beginning, the nanomaterial means we can use very less amount. So we have started some experiments with nano copper, chromium. Now we are using arsenic, which is a little bit toxic. So we are using nano copper, chromium, boron, CCB. And then we have done a lot of experiments based on this, and we found that it is working fine. And so what is the advantage is that we have to use very little amount instead of there earlier where CCA we are using is around 8%, 7% like that. Here we are using 0.02, 0.05%. That is the advantage. Okay. And then we can use development of sensors. We have done a small work on calixarine functionalized carbon nanotube as a sensor. Carbon nanotube was incorporated with calixarine. This is a molecule like your porphyrin. That means the chlorophyll A type molecule. And then this is attached over that. And then this has introduced along with the carbon nanotubes. Then it formed a composite, and that can be put it in an electrode, and we found that and that is sensing ammonia, trimethylamine, dimethylamine, and different characteristics. So that is TBBN we used to say. And then this is the scanning electron microscope image of the that composite. And this is the first one is how this aligned between the two electrodes. So this is also one of the sensors. I'm not talking about much. Hope. And then major issues, society, the ethical and legal ramifications of nanotechnology are more important under public consideration. Greater awareness and understanding of nanotechnology among the society is essential for safe application and reaping the benefits. Society must be more informed about the advantages and disadvantages of this technology. Also, in during public deliberations, discussions, and suitable decision. And we cannot, at present, we cannot avoid nanomaterial because we have already come across with a large number of nanomaterial in our daily products, daily using products, especially the different types of creams, different types. Even if you purchase one refrigerator, most of the refrigerator surfaces were treated with nano silver. And if you purchase for example, this face creams, whatever, any type of creams, or beauty conscious material, people using different types of creams and gels and solutions, most of them are containing nanomaterials. And they are using very little amount, then they are getting good results. So, in this junction, I stop this talk for. Thank you for your patient hearing. I hope you followed something. If you have any questions, please. Hello? Can you hear me? Hello? Yeah.
Participants, if you have any questions, please ask the sir. Any questions? I think so. There are no questions.
Okay.
Thank you. Thank you so much. Thank you on behalf of the organizing community. Thank you on behalf of students. Thank you so much. Hope in future we will also hear again from you.
Okay. Thank you for giving me opportunity, and thank you for the